So this started the way a lot of my best rabbit holes start, completely by accident. I was researching something totally unrelated. I think it was the history of deep space probes, actually. One of those late-night sessions where you tell yourself you'll just read one article, and then suddenly it's 2 a.m. and you've got 14 tabs open and you're questioning your entire understanding of energy. I was reading about the Voyager spacecraft. You know, Voyager 1, the little machine we launched in 1977 that is right now, as you watch this, over 23 billion kilometers from Earth. Still sending back data, still communicating, still alive. And I found myself asking a question I'd never thought to ask before. How is it powered? Out there, past Neptune, past the edge of the solar system, there's no sunlight worth speaking of. Solar panels are useless. There are no fuel cells, no wind, no battery that could last 47 years. And then I found the answer, and I just sat there for a second. Heat. That spacecraft is powered by heat, specifically by the difference in temperature between a radioactive source and the cold of space. There are no moving parts, no turbines, no pistons, just a temperature difference, and electricity comes out the other end. The device is called a thermoelectric generator. And I remember reading that phrase and thinking, wait, that sounds incredibly simple. Why don't people just use these, like at home, on a campfire, on a wood stove? So I started digging. And what I found surprised me in the most quiet, understated way. Not because it was some suppressed secret or hidden conspiracy, but because it was so obvious, and yet somehow, almost nobody talks about it. Here's what I want to tell you right now before we go any further. You can buy the core component for this, the actual heart of the system, for about $13. Sometimes less. I've seen them for $9. You can order it online. It'll fit in your palm. And if you have basic wiring knowledge, or honestly, even if you don't, you can connect it to a phone charger output in an afternoon. No special tools, no electronics degree, no permit. A wood stove you already own. A candle, in theory. A campfire. Any heat source you have sitting around, that's your fuel. By the end of this video, you'll know exactly what to buy, where to buy it, how to wire it, and how far you can realistically take it. I'm going to give you the science, the history, the build, and the honest truth about what it can and can't do. Let's go. After that first night of research, I called a friend of mine who does a lot of off-grid stuff. He has a cabin. He's the kind of person who has strong opinions about inverters, which is a very specific kind of person. I told him what I'd found. I said, I think you can generate electricity from a wood stove using a $14 chip. There was a pause. He said, yeah, you can. People have been doing that. And I felt that specific frustration of Solar panels were fragile, unreliable, and useless beyond the inner solar system. Batteries died. But thermoelectric generators, powered by the steady, predictable decay of radioactive isotopes, could produce electricity for decades with zero moving parts in the vacuum of space at temperatures no human technology could otherwise survive. These devices are called RTGs, radioisotope thermoelectric generators, and they have powered some of humanity's greatest achievements. Voyager 1 and Voyager 2, the Cassini probe that orbited Saturn for 13 years, the Curiosity and Perseverance Mars rovers, the New Horizons spacecraft that photographed Pluto, the Apollo lunar surface experiments that ran for years after the astronauts left. Every single one of them powered by the Seebeck Effect, by the same principle as your $13 chip. The military also took notice. The United States deployed thermoelectric generators at remote Arctic weather stations in the 1960s, where conventional power sources were impractical. The Soviet Union used them extensively throughout Siberia, lighting remote lighthouses, powering navigation beacons in places where no grid would ever reach. Simple, reliable, silent, fuel optional. So let's talk about how it actually works. Because once you understand it, it becomes one of those things you can't unsee. At the heart of the bigger the heat sink, the more effectively it keeps the cold side cool, the bigger the temperature differential, the more electricity you produce. A standard 40mm by 40mm thermoelectric module with a good heat sink and a heat source around 300 degrees Celsius will typically produce between 3 and 6 watts of continuous power. That's enough to charge a phone. Slowly but steadily. Here's the honest question. If this technology has been around since 1821 and NASA has been using it since the 1950s, why isn't it more common? Why didn't anyone tell you about it? The answer isn't dramatic. It's actually pretty mundane. Efficiency. A thermoelectric generator, even a very good one, converts only about 5 to 8% of the heat energy passing through it into electricity. A steam turbine converts maybe 35 to 40%. A photovoltaic solar panel, depending on type, converts 15 to 22%. By those numbers, thermoelectric is the worst option in almost every scenario. When you have abundant energy, when you're connected to a grid, or when you have strong sunlight, it doesn't make economic sense to use a technology that wastes 93 cents of every energy dollar. The grid won. Solar is getting cheaper every year. In a connected, centralized energy world, the niche for thermoelectric shrinks. But that efficiency argument only holds when energy is abundant. When your heat source is already there, when you're burning wood anyway, when your engine is already producing waste heat, when you're running a campfire for warmth, that 5 to 8% extraction is free. You are throwing that Anywhere heat is trying to flow from hot to cold, which is everywhere, always, without exception, there is, in principle, a potential, a voltage waiting to be extracted. Your campfire has a voltage. Your car exhaust has a voltage. Your skin, on a cool morning, has a voltage. Most of it will go to waste. That's fine. That's thermodynamics. But some of it, for $13 an afternoon and a little curiosity, doesn't have to. Once you understand the Seebeck effect, you start looking at heat differently. Not as something to manage or contain, but as something in motion. Something going somewhere. And occasionally, if you put the right piece of material in its path, it'll leave something behind on its way through.